Welcome to this section on the squad dataset. You can follow these links to go to the web pages we are going to look at in this section. SQUAD actually stands for Stanford Question Answering Dataset. It is a reading comprehension dataset consisting of questions posed by crowd workers on a set of Wikipedia articles where the answer to every question is a segment of text or span from the corresponding reading passage, or the question might be unanswerable. So the SQUAD version 2.0 combines the 100,000 questions in the SQUAD version 1.1 with over 50,000 unanswerable questions rated adversarially by crowd workers to look similar to answerable ones. To do well on SQUAD 2.0, systems must not only answer questions when possible, but also determine when no answer is supported by the paragraph and abstain from answering them. Here we could explore SQUAD 2.0 and some of its model or some model predictions based on models which have been trained using this SQUAD 2.0 dataset. So here we could explore SQUAD 2.0. We have the different topics where our contexts are being drawn from. Like if you take construction, you have this construction as a process of constructing a building and all of that. So this is about construction. And then right here we could see some model predictions. If we take this, for example, the bird model by Google AI. Let's select the topic pharmacy. For example, we have the word pharmacy is derived from its root word farmer and all of that up to this. Now, what word, this is the first question. What word is the word pharmacy taken from? So the ground truth is meant to be its root word, like this, its root word, or you could say farmer, because if you ask what word pharmacy is drawn from, you could say its root word, or you could say farmer, or you could say its root word farmer, like this is its root word farmer. This is the option just farmer. This is another option farmer, and this farmer. Now the prediction in this case, based on this bird, is actually no answer, which is not good. So this is a wrong prediction. Now let's take this other example. What goods were sold in a farmer? The ground truth answer is ingredients for medicines, so tobacco and patent medicines, while the prediction is tobacco and patent medicines. Now they colored this orange to show that the prediction is almost correct but not perfect. Now for this we have a perfect prediction, that's why you have this green right here. So what did the Greek root pharmakos imply? We have this prediction sorcery or even poison. So one of the ground truth answers matches with this prediction, so that's why we have this green to indicate that this is a perfect prediction. This one's wrong, perfect, and many other perfect predictions. So this shows us what we could achieve by using this bird model by Google AI. Now let's navigate again. Let's select, for example, this by Microsoft Research. Let's go back to that pharmacy. We have this. You find that you actually have this come out correct. That is, what word is the word pharmacy taken from? We have the prediction farmer, which is good. But we also have these other questions which were correctly gotten by the bird model, which here unfortunately don't get correctly answered. We also have this, which is this some sort of almost correct answer. So that's it. We see how these models are doing quite well. And this model, for example, has an F1 score of 83.5%. Let's take a look at this article by Pranav Rajpurkar of Stanford. We look at the SQUAD setting. Here, for example, we have how did some suspect that Polo learned about China instead of by actually visiting it. The correct answer is through contact with Persian traders. So that's it, actually selected right there. Now you could actually read this article in full. We also have this challenges by SQUAD. If you look at this example, we have the ranking cycle is sometimes referred to as a practical kernel cycle. The question is, what is a Rankine cycle sometimes called? So for the question, unlike with the initial passage where we had the Rankine cycle is sometimes referred. So here we use referred to as, whereas the actual question comes with called. So they actually mean the same thing, but we are going to have to solve this challenge of making the machine understand that this referred, for example, in this context actually means the same as called, and based on that produce the result practical Carnot cycle as the answer to this question. Now, on a challenge like this one, we have the European Parliament and the Council of the European Union have powers of amendment and veto during the legislative process. Now the question is, which governing bodies have veto power? You see that right here is going to be very difficult for the model to actually know that this governing bodies is basically represented by this European Parliament and the Council of the European Union. So it's going to be difficult for it to actually answer this question properly. Note that this kind of lexical variations we have put forth, like in this example and this other example, make up about 33% of the questions. Now there's also this category of questions with no syntactic variation, which are actually easier for the models to predict correctly. So here we have the context: students trunked to Wittenberg to hear Luther speak. The question is, who went to Wittenberg to hear Luther speak? We see that the question and the passage have matching syntactic structures. That is, who went to Wittenberg, like here, who went to Wittenberg, while in the context we have students trunked to Wittenberg. So it's quite easier for the model to correctly respond to this question and give the answer students. Now we also have the syntactic variations. So here we have this no syntactic variations where there is no great difference in structure with the question and the actual text. For this kind of problems where we have, or this kind of examples where we have syntactic variations, like in this example we have, during the mass high school education movement from 1910 to 1940, there was an increase in skilled workers. The question is, what impact did the high school education movement have on the presence of skilled workers? This type of examples actually are more difficult to predict correctly, since there's a difference in structure between the question or between the context and the question. Then finally, there is this multi-sentence reasoning, and for this kind of questions we need to use multi-sentences in the passage to answer them. In this example, we have the V&A Theater and Performance Galleries opened in March 2009. Now, after this, we could have some text included right here. And then after, we have, they hold the UK's biggest national collection of material about live performance. So we have this initial text, and then we have some other text in here which could even be longer than what we have already here. And then we have this. And the question poses, what collection does the V&A Theater and Performance Galleries hold? The right answer here should be the UK's biggest national collection. Now, supposing that we have this text here and then we have some long text before this one, you find that this is another case where our model will find it difficult in correctly predicting the right answer. Also note that it's actually a great idea to have such kind of examples in the data set, because they actually represent the kind of problems we may face in a real-world reading comprehension problem. Here we have the diversity of the answer types. We have common noun phrases, which are the highest, followed by other entity, followed by person, followed by other numeric, followed by dates, followed by verb phrase, location, adjective phrase, clause, and then others. You could look at the squared paper right here. We also have the data set, which could be downloaded from this, and then also the dev set right here. Now, if you want to be part of the Squared 2.0 challenge, you could go ahead and follow up these instructions right here. And here are some of the results from this challenge. We have the first position occupied by FPNet, that's by Ant Service Intelligence Team, whose model is called the FPNet. It's actually an ensemble model that is a mixture of a combination of several models. Notice how they have an EM and F1 score, which is actually greater than the human baseline. We also notice that we have many of these models which surpass the human baseline. If we take, for example, the F1 score for the human baseline of 89.45, if we want to rank it based on these models, let's take this 89.45. Going down, we have this, and there we go. This is the exact position we're gonna have, which is the 20, we could say 20 seat position. So that's where the human baseline ranks itself. When we download this data set, what we obtain is this JSON file. As we could see here, we have this dictionary where we have the version given to us. We have this data. Now note that for this data, it's made up of a list, and this list is made of several dictionaries. Each dictionary has to do with a topic, or what they call here a title. So for the first topic, we have Beyonce. If we do a search on title, we'll have, let's add this. So let's have it like that. Okay, so we notice that here that when we do a search on title, we have 2 out of 442 options. So actually there are 442 different titles. That is 442 different topics. For this, we have Frederick Chopin. We go to the next title. It is the Sino-Tibetan relations during the Ming Dynasty. And then next one, we have this. Next is this. Next, the Spectre 2015 film. So basically, what we have is this JSON file made of this data, and where the data is composed of a list where each element of this list contains information based on a given title. So if you look at this first title, that is Beyonce, we'll also notice that we have this paragraph. So for this title, we have this paragraphs. Now this paragraphs tool is made of a list which has elements question answer, and those question answers are linked to a context. So let's search for context. Right here we have this. Okay, so there we go. We have this list right here. Now if we tap on this, we see that this list, you see that this list actually is related with this. So we said this list that we have here is made of this dictionary, and this dictionary is composed of a question, as we could see, and answer, and this is impossible tag. Now we've linked this right here. There we go. So for the first question, we have, when did Beyonce start becoming popular? And the answer is, as we could see right here, in the late 1990s. Now this question is linked with this answer, and then this next question we have, what areas did Beyonce compete in when she was growing up? The answer we have here is singing and dancing. So we have this other question linked to this answer, and then we could go on right up to the end, or right up to the end of this list right here, where we have this last question, what was the name of Beyonce's first solo album? The answer is Dangerously in Love. So that's our question and answers. Now this question and answers are linked to a given text, and that text is what we have here as a context. So this context is basically this: Beyonce, Giselle Knowles Carter, pronounced Beyonce, born on September 4th, 1981, is an American singer, and all of that. So we have this context right here, and this ends up at this point right here. So we click on this, you see that it's actually linked with this. So this is our first paragraph. Now this first paragraph is basically made of this context, that is this, and then this questions, where we have this question, and then we have the answer right here. Then after we're done with this paragraph, we can move on now to the next paragraph, where we have some more questions. Like in this one again, we have this first paragraph right here. The next paragraph, as you could see, this is a list of paragraphs. We have this first dictionary here. See how this is linked actually with this. So we have this first dictionary. This is the question answer, and then we come again to this question answer again. Right here we have the questions, and then we go right up to the context. Let's search for context so we could get to that quickly. So there we go, we have this other context right here which ends up to this point. So we have this next one which is linked with this, so we see the link between this and this. Here again we have the context, and then we have the questions and answers which come before. Now what we're going to do is we're going to convert this data set in a form in which TensorFlow can be used to easily exploit this data. Now the way we've done this is by putting it in this form. So here we have the context. See, we go swipe right to the end. We have this context. So notice that we start with this Beyonce, Giselle, Knowles, Carter, and then we end up with this Crazy in Love and Baby Boy. So let's come back to our first context we had right here, Beyonce, Giselle, Knowles, Carter, and then we end up with this Crazy in Love and Baby Boy actually. So this matches up with what we have. And then we have this first question. When did, actually this is something we just, it's normally this, we're trying to test a certain bug, so we modify that. Normally does that. So we have that. So we have, when did Beyonce start becoming popular? That's the first question we have. And then we have this 44, 47. Let's explain why we have this 44, 47. Now if we come back to this, we have our first question right here. When did Beyonce start becoming popular? Which matches exactly what we have in the data set, or the new form of data set we just created. So we have this, when did Beyonce start becoming popular? And then for the answer we have in the late 1990s. If we come to this context and we have to count each word, so if we go word by word, this word, we count up to the point where we have this in the late 90s, because here is the correct answer, in the late 90s. We'll find that this is the, if we start from the point, if we start from 0 up to this, we will have 0, and up to this point we reach at the point where we have 44. So there will be 44, 45, 46, 47, and that's basically what we do. What we do is we go through the context, or we go for each question we locate it in the context, and then we generate its position. So in this case we have 44 to 47. The 44 represents the starting position, and the 47 represents the last position. So that's how it works. 44, 47 for each question, for this question. Now we move to the next question, where we have, what areas did Beyonce compete in when she was growing up? Now this one, the answer is singing and dancing, and that matches with 33, 35. So this should be before this 44, 47. So if we have to get back here, we have this in the late 90s. We'll go back a bit. We see that it matches with this. So this is 35 or 33 as was given. So we have 33, 34, 35. And then we follow this up with 36, 37, 38, 39, 40, 41, 42, 43, 44. So that matches with in the late 90s. So basically that's how we treat our data set.